is June 2013, and this is paper 2, which is the calculator paper. So, number 1, this formula is used for working out the cost in pounds of repairing a car, and they give us this formula. Okay, so N is the number of hours worked, L is the labour rate in pounds, and P is the cost of parts in pounds. Okay, so 1A, work out the cost of repairing a car when N equals 3, L equals 18, and P equals 110. Okay, so this is quite simple. All we do is we have our formula here, so we know C is the cost. So we now substitute in the values in this formula. So I would just write the formula again. So C equals NL, let's just make sure I get this right, plus 1.2p plus 1.2p. So we can say that the cost equals, now N is 3, and NL is N multiplied by L. So L is 18, so that would be 3 multiplied by 18 plus, now 1.2p is 1.2 multiplied by P, which is 110. So now all of our letters up here have now disappeared, and we have real values. So C equals, now 3 times 18 would be 54, plus, now 1.2 multiplied by 110, so we know we can use our calculators. So 1.2 multiplied by 110 gives us 132. So we can then say that C equals, now 54 plus 132 will give us 6, 5 and 3 is 8, and 1. So our answer would be £186. Okay, really is that simple. We just substitute in the values accordingly. So now question B, complete the table for this other repair. Complete this table for another repair. Right, so here we have the cost, but we don't have N, so they want us to work out what N is. We have L and we have P. So we rewrite the formula. So C equals NL plus 1.2p. Okay, so make sure I've got that right. Now we want to find N. So N is here. So the first thing I want to do is N is positive. So I want to move this over the other side. So I arrange the formula first. So we will get C Now if this comes over, it will be minus 1.2p. And then we've got n multiplied by L. Okay, well let's just write this in. So I've moved the 1.2 so you can see that. Now the n and the L are multiplying. So if I move the L over to give us just the n here, instead of multiply, it divides. So C minus 1.2p all divided by L will give us n. Okay, so this is where we get making something the subject of a formula or an equation. So now we have all our knowns on one side and the unknown on the other. So C I know is £235. Now from that we have to subtract 1.2p. Now p is 150, so I've got to multiply that by 1.2. So 150 multiplied by 1.2 gives me 180. Okay, and this is going to be divided by L, and L is 22, so we have 22, and this will equal n. So now it's just arithmetic, so 180 taken away from 235 will give me 55 divided by 22, and that will equal n. Now we have this improper fraction, so we need to cancel this down. So what we need to know is there a number that will go into 55 and 22? Now I know 11 will go into 22, 11 will go into 55. So 11 will go into 22 twice, and 11 will go into 55 5 times. So this gives us 5 over 2. Yeah? So 5 over 2 is 5 halves. So 5 halves will give me 2.5. So n will equal 2.5. Now remember, this is in pounds. Okay, if we go back to the original point here, oh sorry, n is the number of hours worked. Okay, so we've got 2.5 hours. Okay, so 2.5 hours, so we could just write 2.5 hours, or we could write 2.5 hours or 2 hours and 30 minutes. That would be acceptable. Okay, so there's 5 marks on those 2 questions. So this algebra here, rearranging a formula, is important. So everything in mathematics is connected to everything. Okay, so you need to know this part of the algebra to solve this part here. Okay, so let's move on to the next question. So I'll just pause it so we can go to the next question. Okay, so we've got question 2. So the scatter diagram, so we have the scatter diagram here, shows the scores of 10 students in their oral and written tests. Okay, so we've got our graph here. So here along the bottom are the possible results for an oral test from 0 to 100, and again for a written test 0 to 100 going up here. So for example, somebody here, okay, gained 30 marks in their oral but only 20 marks in their written. Okay, and you can do that with all of these points. So the first question, how many students scored 50 in their oral test? Okay, so here, if we go to 50 in their oral test, okay, we have one student that scored 50 and then another student that scored 50. Okay, I know they got different marks in their written tests, but in their oral test alone there's 1, 2 students. So I just check that there's no outliers. No. So 2 students gained 50 marks. Okay. Now it says here 4 more students take the same test and the table shows their scores. So we have to plot these scores on the scattergram. So one student got 10 and 15 on the written. So one student got 10 on the oral and 15 on the written. So that would be around there. One got 94 oral and 90 written. So 94 would be about here, and got 90 on the written. Okay, so 94 would be on this line here, and got 90 on the written. One student got 52 and 46. So I go to 52, which is here, and 46, which is here. It's important when you look at these graphs you understand what all these subdivisions are. So from here, from 50 to 60, obviously is 10 marks, but we only have 5 lines. So this must be 2 marks, 4 marks, 6 marks, 8 marks, 10 marks. Okay, and the same goes for the vertical. And then we have one student got 84 and 80. So 1 mark. So 84, we go up here, and 80, so I believe that's about there. Okay, so we've shown that, so we've got 2 marks. Okay, so now we finished that part of the paper. Now I will bet £1,000,000 that there will be another question about this. So I'll go to the next page. Okay, so I'll just pause it a second. Okay, so as I thought, 2C, draw a line of best fit on the scatter diagram. Okay, so we need to draw the line of best fit. Now the best line of best fit is by eye. If we were to connect all these dots, we would get a very zigzag line. So what they want is the best possible straight line that we could get running through. Okay, so we want as many crosses above the line as beneath the line. You might hit some lines, some points on the way through, but you won't hit them all. Okay, so this is just literally done by eye. Okay, now this particular point is an outlier. It's way out of the rest of these lines, so I ignore it. So I'm just going to draw a line that I think is more or less running through the points. Okay, that's roughly it. Okay, I've hit a couple of points here, I've got a couple of points here, I've got a few more on this side, so maybe the line could have gone slightly higher. Okay, but I'm doing this on a PC, so I'm limited to how long a line I can put on it, but you'll get the idea. This is roughly through the centre of the line. Okay, and examiners know that this is by eye. Okay, so then we get to the question. Rob scored 40 in the oral test and he was absent for the written test. So use your line of best fit to estimate. Okay, they want an estimate of his score for the written test. Okay, so this estimate means that they know that your line is only accurate to a point. So if he scored 40 in the written test, okay, so we go to the written test. Now he scored 40 marks. Okay, so I draw a line from 40 and I use my line of best fit now as a guide to what his possible score was. Okay, so here if he scored 40, this line is saying, okay, this is the spread of data and this would predict the results of any student that didn't sit one of the exams. So if he scored 40 on the written, according to this line, he would have scored 40, 42, 44 marks. Okay, so I would say that he scored 44 marks. Now if you look at the exam mark schemes, you'll see that they have a margin for error, so this is not cast in stone. They might have anything from 38 to 48, say, because your line will be slightly inaccurate as mine is. Okay, so that's how we find out the information. So the line of best fit will help us find missing scores should somebody miss one part of the data that we've collected. Okay, I hope I've not made that more complicated than it actually is. Okay, so we move on to question 3. So Andrew is planning a survey about his local library. Here is one of his questions with the response question section. So how many times do you go to the library? 1, 2, 3, 5 or more. Okay, so give one criticism of the question. So this is really you picking holes. This is your opinion. So how many times do you go to the library? Well, this is not a very good question because it's assuming that everybody goes to the library. Okay, so I would say that the question assumes everyone goes to the library. Okay. Give 2 criticisms of the response question. Okay, so the response is here, 1, 2, 3, 5 or more. Now, because the question here assumes that everybody goes to the library, there is no box to be ticked for never, because not everybody belongs to a library, and if they do, they don't go, or sometimes they're sporadic. So one criticism is there is no box for never. Okay, now that also means that I can add a piece here. The question assumes everybody goes to the library or is a library member. Okay. Now the other thing is how many times you go to the library. So is that once a week, once a day, once a year, once a decade? So this has no relation to time. Okay, so again, just write this in ordinary straightforward English so I can say the responses are not time related. Okay, or you can say the first box doesn't say whether it's once a day, once a week, once a year. You can just write that. Okay, they're not looking for some very high mathematical theorem here. They just want written in English what is wrong. Okay, so first, there is no box for never. So whenever you formulate any sort of questionnaire, you should always have a question, a box to be ticked which has never or zero or none. Secondly is, if you're going to do something like this, you need to relate it to time. Okay, because this is very vague. Okay, so this is quite easy because you just choose what you think are the faults. So it's just common sense. You don't need to be a mathematical genius to work this out. It's just logically, does it make sense? Okay, so I'll stop the video here and then I'll go on to the next set of questions in the next video.